Welcome to The Explainer. Today we're taking the sci-fi dream of teleportation and stacking it up against cold, hard physics. We hear about it all the time, right? But is it actually possible? And, maybe more importantly, if you stepped into a teleporter, would the person stepping out on the other side actually be you? So let's break down the science, the crazy societal impacts, and the frankly terrifying paradoxes of instantaneous travel.
Okay, here's our roadmap for this explainer. 1. The teleportation dream. 2. Impacts on human society. 3. The quantum reality. 4. Section 4. And 5. The identity paradox. Let's get right into it.
Section 1. The teleportation dream. From fiction to physics.
You know, the difference between these two concepts really hits the nail on the head when it comes to the massive gap between pop culture and reality. In sci-fi, teleportation is basically treated like a futuristic cargo system, right? Moving actual physical matters seamlessly from point A to point B. But real-world quantum physics? No way. We're not sending parcels of matter. We are sending complex quantum information. The original atoms literally don't travel. Instead, a machine reads the precise pattern of a particle, sends that data, and then reconstructs that exact quantum state using entirely different atoms at the destination. And here's the kicker. Because of the strict laws of quantum mechanics, simply reading that initial state intrinsically destroys the original in the process.
Section 2. Impacts on human society. A borderless world.
Okay, before we get bogged down in the heavy math, let's talk about why we're so obsessed with this idea. Consider the massive domino effect of these benefits. It would completely eliminate time and cost barriers, meaning no more daily commutes, which would drastically cut global carbon emissions. But I really want you to focus specifically on point 4. It radically enhances social connectivity. I mean, imagine living in Vermont, working in Texas, grabbing lunch in Brazil, and on a global scale being able to instantly deploy humanitarian aid the literal second a crisis hits anywhere on Earth. The world becomes this intimately connected, completely borderless community.
But of course, there's a catch, right? This level of access has a massive geopolitical cost. The whole concept of a traditional national border would just vanish. Instead, whoever controls the teleportation nexuses, these physical hubs where the travel actually happens, they'd essentially dictate global supply lines and trade. As world-building analysts have pointed out, these nexuses would become modern, fortified city-states. We're talking heavily guarded choke points that would completely reshape international alliances based on who gets access to the grid.
All right, Section 3, the quantum reality, the atoms and the math.
So how do we actually pull this off? Think about the sheer scale we're dealing with. 10 to the 28th power. That is roughly the number of atoms in a human body. To teleport you, we would need to perfectly scan, encode, and transmit the exact three-dimensional location, energy level, and spin state of every single one of those atoms. Even if we assume just 1 kilobyte of data per atom, transmitting a human would take over 2,400 times the current age of our universe using our best modern commercial computers. The storage required is just beyond astronomical.
And this quote right here really sums it up perfectly. The hardest part isn't the distance, it's the person. Moving the data is tough, sure, but the sheer biological architecture of a human is the ultimate roadblock. Your memories, your skills, your consciousness, they all depend on roughly 100 trillion synapses in your brain. Recreating a person requires a scan so incredibly precise that it captures all of that biological structure perfectly without disrupting it prematurely.
Which brings us to Section 4. Because despite these massive numbers, quantum teleportation isn't just theory. It's happening right now in labs all over the world with individual particles.
Consider the classic experimental setup using the standard physics characters we like to call Alice and Bob to map out exactly how scientists teleport a photon's quantum states. Basically, it involves firing a UV pulse into a crystal to create an entangled pair of photons. Let's just call them A and B. When two particles are entangled, they're part of the exact same quantum system. So whatever happens to one instantly affects the other, even if they're miles apart. Alice takes photon A and Bob takes photon B.
Let's walk through this protocol to see how the magic actually happens. They generate that entangled pair and distribute it. Then Alice introduces a third photon, which is the message she wants to teleport. Now pay super close attention to step 4 in this protocol. Alice performs a measurement in the Bell basis. This is absolutely crucial to the whole shebang. By performing this specific measurement, she forces her two photons to interact, which collapses their state and, just like we talked about earlier, destroys the original information. Because of quantum entanglement, this instantaneously affects Bob's particle far away. Finally, Alice just calls Bob on a normal communication channel to share her results, giving him the exact instructions to apply the right quantum logic gates and transform his particle into a perfect replica of Alice's original.
And finally, Section 5, the identity paradox. Are you still you?
We've covered the societal benefits and the rigorous math, but if computing power ever caught up and we actually scaled this to human teleportation, we'd be facing a terrifying philosophical nightmare. This brings us to the Teletransportation Paradox. Coined by philosopher Derek Parfit back in 1984, this thought experiment asks a truly chilling question. Remember, the physics requires the original quantum state to be destroyed. So, does the original you effectively die in the scanner on Earth, while a brand new clone built from local Mars materials wakes up on the red planet? That replica has all your memories, your personality, your exact atomic structure. They will confidently claim to be you. But from your perspective, did you just step into an execution chamber?
Well, it all boils down to how we define consciousness. Are you simply a collection of atoms, or are you the arrangement? If consciousness is just a pattern of information, then teleportation is perfectly safe. It's like a photograph, captured in one place and printed in another. It's still the same image. But think about the candle flame analogy. If you blow out a candle and immediately light a new one, is it really the same flame? A lot of people argue that human identity requires an unbroken, continuous process. Breaking that physical continuity means the original is truly gone forever, even if a perfect replica carries on.
So I want to leave you with this provocative final thought. Knowing everything we've just unpacked, knowing that the quantum protocol absolutely demands the destruction of your original biological makeup, and that the person walking out on the other side is physically a brand new construct, if the technology existed tomorrow to instantly whisk you to a beach in Hawaii, would you press the button? Or would you be too afraid of who or what is actually waking up on the other side? Thanks for joining me on this explainer. Keep asking questions and keep exploring.